class, this is a homework example from section 3B. This is problem number 6. Okay, you may not have the same numbers as this, but it's the same work that you got to do to get the answer. So what we're doing here is we're approximating big numbers being multiplied together, and we're using scientific notation to do that. So just for reminders review, in scientific notation is defined to be a number between 1 and 10, right? 10 not included, multiplied by a power of 10. So things like 2.57 times 10 to the 8th, right? That kind of thing. This first number must be between 1 and 10. Okay, you can't have a number like 37 times 10 to the 3rd. You can't have a number bigger than 10 or smaller than 1 being multiplied by that power of 10. So that's what we mean by scientific notation. Alright, now what we're being told to do is to multiply these without using a calculator, and then find a more precise result using a calculator. So for part A, I got each one of these A, B, and C on different pages. But for part A, 300,000 times 100. So 300,000 and 100, they're already whole numbers. Okay, so like down here you see we're going to have to round these others. 300,000 and 100 are already whole numbers, so the approximate value and the exact value are going to be the same thing. Alright, so remember, when you have a whole bunch of zeros in the numbers you're multiplying, you just multiply these non-zero digits. So 3 times 1 is 3, and then you just count the zeros. There's 1, 2, 3, 4, 5, 6, 7 zeros. Alright, but that tells us to use scientific notation. So in scientific notation, the number between 1 and 10 here is going to be 3. And then 3 times 10 to a power. Power is how many places. If I put a decimal point right there, now that's the number 3. Okay, how many places do I need to move that decimal point to get back to the number that it actually was? So that's 1, 2, 3, 4, 5, 6, 7 places. Which in this case, because everything was just zeros after this, you could just count the number of zeros, and that's your power. Alright, and because, again, these were whole numbers, the approximate value is the exact value. So 3 times 10 to the 7th. Alright, now the third question here, when you do these, you'll do an approximate exact, and the third will be, did the approximation work? And then that will always be something like yes or no, depending on if it was close. Okay, it's always going to be yes because the approximate answer is close or equals, in this case, the exact answer, or it's going to be no because it's not close. Okay, but that'll be your two choices for if it does or doesn't work. It's close, or in this case equal, or it's not close. Alright, for part B, we're told to approximate 5.6 million times 1.9 thousand. Well, first thing we need to do is write these two numbers that we're multiplying in scientific notation. Okay, remember million, that's a number like 1 million. Has 6 zeros after it, so when you see the word million, you can replace that with times 10 to the 6th. And then 1,000 has 3 zeros after it. So we can write 1,000 as, or 1,000, we can replace that with times 10 to the 3rd. Alright, now, after we do that, for the approximate version of this multiplication, we're going to round these two numbers. So 5.6 rounds to 6, 1.9 rounds to 2. Okay, and then we multiply. This number times this number, and then we're going to do the powers of 10 because of the ease with which we multiply powers of 10. So 6 times 2 is 12, times 10 to the 6 times 10 to the 3rd is 10 to the 6 plus 3. Okay, we just add these two numbers, 6 plus 3. But instead of writing that, I'm going to write that as 9. Alright, now, so there's what we get, but remember, go back to the front page. A number between 1 and 10 multiplied by power 10. So 12 is not between 1 and 10. So to make it between 1 and 10, we'd have to put a decimal point right there between the 1 and the 2. Now we got a number between 1 and 10, but they have to be equal. Notice the equality sign in between them. If 12 was being multiplied by 10 to the 9th to give us our number, 1.2 would then have to be multiplied by 10 to the 10th. Remember, this number right here is how many places we need to move the decimal, which was decimal point, which was right there and originally, to get back to the actual value. I would have to move it 9 places to the right if it was right there, but it's one more place to the left now, so I have to move it 10 places to the right. Okay, so if you have to move this decimal after you've multiplied because you got a number bigger than 1 or 10 here, you have to compensate by raising that power one number. Alright, so there's what we get, 1.2 times 10 to the 10th. The exact value, now it's time to use the calculator. Okay, so I'm going to pull up my calculator and multiply the two digits. The two numbers that are not just power to 10. So 5.6 times 1.9 is 10.64. Alright, so I'm going to write 10.64 times, again, million times thousand, 10 to the 6th, 10 to the 3rd. It's still going to be 10 to the 9th. So just like before, we're going to need, this is bigger than 10, so we're going to need to move that decimal point back 1, so 1.064, and we're going to have to raise this power to compensate. Alright, so again, scientific notation has to have a number between 1 and 10 here. If you have a number bigger than that after you've done multiplication or addition, then you need to compensate by moving that decimal point. Alright, same thing works if you had division and you ended up with a number less than 1, like some decimal where you had a decimal point and possible several zeros. You still need to get a number between 1 and 10. So you have to move that decimal point back and forth. To make sure you have a number between 1 and 10 here, you just compensate by changing this power. 10 to powers, just move a decimal point left and right depending on what the power is. Alright, and then it says round to the hundredths place. So there's the hundredths place, so we would write this as just 1.06 times 10 to the 10th. Alright, a lot of you are getting problems wrong in this section because you're just not paying attention to where you're supposed to round. Alright, and then part C, the approximate value. So once again, I'm going to round this. Alright, 1.7 rounds to 2. So I'm going to divide 4 times 10 to the 9th by 2 times 10 to the 6th for my approximation. And again, the way I do that is I divide the things that aren't 10 to power. So the 4 divided by 2 is 2. And then the 10 to the 9th divided by 10 to the 6th is 10 to the 9 minus 6 this time because it's division. Once again, I'm not going to write that as 9 minus 6. I'm going to write that as 9 minus 6 is 3. So 2 times 10 to the 3rd is our answer. Alright, and then same thing if I want to do an exact value. I'm going to take the 4 and divide by the 1.7. We get that number, 2.353, roughly. And then times, same thing, 9 minus 6 is 10 to the 3rd. And then it tells us to round to the nearest tenths place, that's right there. So that's going to be 2.4 times 10 to the 3rd. Alright, and then always ask at the end, do the approximations work? Alright, this was part B, the 1.2 times 10 to the 10th, 1.06 times 10 to the 10th, they're exact. Did the approximation technique work? Yes. Okay, again, they're close. It doesn't really define what close is here. Typically, it's like within 5%. And then the last part, there's the 2 times 10 to the third, 2.4 times 10 to the third. Did the approximation technique work? Yes, because it's close. Okay, again, they're not defining here what close is, but typically it's within 5% of the exact value is what we consider close. That's what we usually use for like statistics anyway. Alright, that's again problem number 6 from 3B homework. So if you have any more questions about it, just send me an email.